Systems of Inequalities and Linear Programming is a lesson I forgot to do before, so we're doing it right now. And we're just not going to cover the linear programming part, but this is the lesson that goes with that worksheet that I gave you the day of the test. So it's pretty straightforward. Hopefully we'll get through it pretty quick. Okay, so the following is a system of linear inequalities in two variables. Okay, it's very similar to a system of linear equations, only instead we have the inequality symbols. Okay, so a solution of a system of linear inequalities is an ordered pair that is a solution of both inequalities in the system. So, is 3, -1 a solution to this system? Well, all we have to do is plug in our x and our y to see. So first we have x and y less than or equal to 6. So this is going to be 2 is less than 6, and that's true. So that one checks out. So now we just need the other one to check out and we'll be in good shape. So now we have 2 times 3 minus a -1. Is that bigger than 4?
Omar Naranjo, please dial 350.
Sorry, I'm not starting the video over again.
Please dial extension 350.
You can just listen to the announcement. Okay, sorry. All right, so we've got 6 plus 7, that's bigger than 4, so that also works. So yes, 3, -1 is a solution to this system. All right, so how to graph systems of inequalities. You can write this down if you want to stop the video. It's pretty straightforward though, and I guess I can read it. Graph the line that corresponds to the inequality. So you just pretend that the inequality sign is an equal sign. If it is less than or greater than, use a dotted line. If it's like this, use a solid line. Pick a point not on the line. Usually we use 0, 0. If it makes the inequality true, shade that side of the line. And if it doesn't make the inequality true, you shade the other side. And then use different, you don't have to use different colored pencils, but you can use different colored pencils or different angled lines to shade so you can see where they overlap. Okay, so again, you can pause the video and write that down if you want. It's easier though just to show you. So, okay, so graph the system. So I'm gonna graph both of these and I'm gonna see where they overlap. So first of all, I'm gonna treat this one as if it's an equal sign right here. Okay, now it is a greater than or equal to, so it's going to be a solid line. Okay, so I have -1, that's my y-intercept, and my slope is -3. So 1, 2, 3, 1, 1, 2, 3, 1. So here is my line for this. And again, like I said, it's going to be a solid line because it has the equal to right here. Okay, so I'm going to test 0, 0 right here. And I'm going to check and see if that's a solution to this inequality. So if I plug in 0, 0, I have 0 is greater than or equal to, this will be 0, -1. Is that true? Is 0 bigger than -1? It is. So that means that 0, 0 is one of my solutions. So I've got to shade this side of my line. And I'm not going to shade it. That would be a waste of marker. Okay? But I do have them going that way. Okay. The next one I'm going to do, I'm going to use red. And we've got y, we're looking basically at y equals x plus 2. That's kind of our boundary. So we've got 2, and then the slope is 1. And this is going to be a dotted line. so that's a dotted line. And again, for me, I like to test 0, 0. So now I'm going to test 0, 0 again. Is 0 less than 0 plus 2, less than 2? It is. So that means that if I'm just looking at this line right here, that 0, 0 is counted. So, I wish my markers worked better. The part that overlaps really is right in here. And it's all of this. Okay? And I wouldn't do curly Q's, don't do curly Q's on your homework, just actually shade it in. But that's the part that is the solution to this system of inequalities. Okay, I'm going to do some more examples then on the next video.